Hey everyone, welcome back to another DevOps and Kubernetes series on TechOps tutorial. In our previous video, we have explained all 12 core Kubernetes objects. So if you haven't seen that yet, make sure to check it out first. I have linked in the description and also added in the card. In this video, we are diving deeper into some must-know concept that I will make your Kubernetes journey smoother, especially if you are a system administrator or a developer working in a cloud-native environment. Here is what we will cover. What happens when you run kubectl get nodes, mandatory fields in every Kubernetes object, common objects used for application developments, and some real world Kubernetes best practice. So let's get started. Kubectl is your main tool for interacting with your Kubernetes cluster. Think of it like your Kubernetes remote control. Everything goes through it. It lets you to create, update, inspect, and delete the resources. It talks to the Kubernetes API server on your behalf. Everything you do with kubectl is a request to the API. Here are some must-know kubectl command. Kubectl get pods. It will list all the pods. Kubectl get svc. It will list all the services. Kubectl describe pod followed by the pod name. It will display the detail info, events, config, and etc. Kubectl apply -f file.yaml. It will apply the changes from a YAML file. You can also use -n to work in a specific namespaces using kubectl get pods -n followed by the namespace. In our case, it is deployment namespace. These are the key features: direct API server communication, resource lifecycle management, and multi-context support. Now let's understand what actually happens when you run kubectl get nodes. Let's break it down step by step. When you run kubectl get nodes, you are not just magically getting a list of nodes. There is a whole flow happening behind the scene. Here is what really goes on. First is authentication. Your kubectl client uses your kubeconfig file to connect to the Kubernetes API server. It sends along your credential like a token or a certificate, and the API server authenticates your identity. And the next is authorization. After authentication is done, Kubernetes check, are you allowed to make this request? Do you have a get permission for the node's resource? This is done via RBAC, role based access control. And the next is the request is then validated by the API server to ensure it's a proper, well formed call. And the next is data is retrieved. etcd is a distributed key value store that stores all the cluster data from the state of nodes to a configuration details. Now that the request is valid and authorized, the API server reach out to etcd, the central database of Kubernetes. It fetches the current state of all the nodes. Next, response is returned to you. Finally, the API server formats the data, usually in a nice table, and send it back to your terminal as the response to your kubectl command. This is why performance depends on both your network and how healthy your control plane is. Even a simple kubectl get nodes triggers a full round trip behind the scene, from client to API server to etcd, and from etcd to API server, and then it will returns to a client. Now once that entire process is complete, here is the kind of output you will typically see. When you run kubectl get nodes, you will get a name, status, role, and the age and the version. You will see other columns like internal IP, OS images, kernel version. If you use kubectl get nodes -o wide, here is what each of the column means. Name. The hostname of the node usually set during cluster setup. It helps you identify which machine you are looking at. Status. This shows whether the node is healthy and ready to accept pod. If the status is ready, everything is good. If not ready, something wrong, maybe Kubelet is down or unreachable. Next is roles. The role of the node is the cluster. Master or control plane means it's managing the cluster. Worker usually shows none. unless you have labeled them. Next is age, how long this node has been part of the cluster. And the last is version, the version of Kubernetes running on this node's kubelet. This command output gives you a high level view of node healthy and versions. For more details, use kubectl describe node followed by the node name. This shows CPU or a memory capacity, allocated resource labels, and more. Great for debugging or understanding how scheduling works. The kubelet is the agent running on each node that talks to the API server. It ensures the container actually run based on the pod specification. If kubelet is down, the node might shows not ready. Next is mandatory fields in any Kubernetes object. Every Kubernetes object, whether it's a pod, deployment, or service, is defined in a YAML, and there are four must-have fields: API version, kind, metadata, and specification. Let's look at a quick example. API version tells Kubernetes what version of object API you are using. For example, apps/v1 or v1. Next is kind, specifies the type of the object, pod, deployment, or a service. Metadata includes the object name, labels, and optionally namespaces. And next is specs, the actual configuration that defines what object should do. These fields tell Kubernetes what you are trying to create and how it should behave. If you miss any of these mandatory fields, your YAML will be rejected by the API server. It reinforces the importance of all four fields. Next is Kubernetes object used in real application deployments. When deploying real application, you will often combine multiple Kubernetes objects together, that is deployments, service, config map. Deployment defines how many replicas you want and manages updates. Service expose your application inside the cluster or to the outside world. Config map, it holds the non-sensitive config data like URL or feature flags. And the secrets stores the sensitive data like password and API token securely. And the PVC we use for persistent volume claim. Let's say you are deploying a simple web app. Your YAML might include a deployment running three applications, service exposing the 80 port, and the config map for environment variables, and a secret storing a database password. This approach keeps everything modular, secure, and scalable. And the next is best practices for working with Kubernetes. Let's wrap up with some field tested best practices that will help you to maintain a clean and reliable cluster. Use namespaces, separate for dev, test, and prod workloads, or isolate application by teams. Store your YAMLs in Git. Use GitOps. Version control your infrastructure and track the changes. Apply resource limits. Set CPU and memory request or limits to prevent overloading your cluster. Use readiness and liveness probes. This helps the Kubernetes know when your app is ready and when to restart it. External monitoring tools, set up a tools like Prometheus plus Grafana for cluster metrics or ELK stack for logging. Avoid hard coding secrets. Use secrets and environment variables securely. Never put password directly in a code. Automate deployments. Use CI/CD tools like Jenkins, GitHub Actions, or AgroCD to automate your delivery pipelines. Use labels effectively. Always label your resources with app, environment, or team specific tags. It makes management and automation easier. Perform dry run before applying the changes. Use kubectl apply -dry -run equals to client -f followed by the YAML file name to test your YAML locally before affecting the live cluster. Let's recap what we have covered. What happens when you run kubectl get nodes, mandatory fields in any Kubernetes objects, how kubectl lets you manage your cluster, which objects are commonly used during application deployments, and the best practice every DevOps engineer or a developer should know. I will share all the details in the description. If you found this video helpful, make sure to like, subscribe, and hit the bell icon so you never miss a new Kubernetes tutorial. Check the description for YAML examples, related videos. Let me know in the comments which concept was new for you or helped you the most. I will like to hear. Thanks for watching and I will see you in the next tutorial.